Greetings and welcome to week 3 unit 2 on analogies, metaphors and graphic organizers. In the previous unit we understood what instructional components are and their role in instruction. To recapitulate, instructional components are elements, you can say. It does not mean that every instruction unit you are not going to use all the instructional components. The instructional components, they serve some purpose, they are relevant at some places depending on the nature of the subject, sometimes the nature of the audience. The teacher, based on his or her experience, will decide what instructional component to use at what point of time. But a teacher should be aware of the variety of instructional components that one can use in the classroom. And one of the purposes is that you have to facilitate the students to engage with the knowledge, not merely listen to passively experience the new knowledge. Okay. To that extent, different instructional components will give different kinds of experiences, but what we are doing, we are introducing a number of instructional components to the teachers now, so they can decide what they wish to do that. Some of the instructional components will require a lot more planning, sometimes some kind of tools and other infrastructure that you need. Depending on that, if you are convinced all that effort is worth it, then the teacher will actually use that instructional component. So, the thing that we are going to look at in this particular unit, three things. These are analogies, metaphors and graphic organizers. Three different instructional components. It does not mean that they have to be used in that sequence at all. Each one can be used in different contexts with different audience in different subjects. One is independent of the other. So, we will first start with analogy. An analogy is a comparison between two different things that have similar relationships or structures used to clarify or explain a concept. Mainly where we use is, you look at something that you are already familiar with. When I am bringing in a new concept, if it is somewhat similar to what I already know of, then I try to relate it to that. So, I am connecting the new knowledge to something that I already know of. It is not exactly same, but it is somewhat similar to that. That is what the analogy is about. The instructional purpose is to map a familiar system onto a less familiar one, allowing transfer of understanding. Let us say everybody is familiar with water flow in a pipe. Okay. Then when I am bringing in the concept of electric current, I am explaining to him electric current is to a circuit as water flow is to a pipe. That is what it is. Okay. I am bringing the concept of current to water flow. So, in the sense I am familiar with water flow, but I am trying to link to a new concept like current in terms of this. We also know that current is not exactly the same as water flow, but it is somewhat similar. That is why as we stated, the analogous components have similar relationships or structures. That is what the analogy is about. Why should we use analogies? They promote conceptual understanding of abstract ideas. If you are trying to use the wrong analogy, you may also kind of you can make the student wrongly appreciate a new concept. So one has to be careful when you try to bring the analogy. Help bridge a prior knowledge and a new content. They also aid in memory retention through vivid imagery. So if I am able to imagine water flowing through a pipe, then I have an image in my brain, and I am relating the same thing like current flowing in a conductor. It is like water flowing through a pipe kind of thing. Enhance cross-disciplinary thinking. So when we are giving an analogy like current with the water flow, we are now looking at something like fluid mechanics or fluid flow, which is a different discipline compared to electrical discipline. Okay. Now let us look at some examples of analogies. Heat conduction is like water flowing through a sponge. The way water moves through a sponge, the heat conduction is also like that. Carnot cycle is like a rechargeable battery being charged and discharged. So if I am familiar with battery being charged and discharged, then I can understand the Carnot cycle in operations similar to battery charging and discharging. The beam under load is like a diving board bending under a person. See, in a diving board, when a person stands, it actually, you can physically see it bending, whereas a beam may not bend that much, but at least is almost exactly similar. Soil behaves like a compressed spring under load. A capacitor is like a water tank filling up and then releasing it. An inductor resists change like a heavy flywheel. If I am familiar with flywheel, then I can, in terms of how the flywheel behaves, I can understand the work of an inductor. Like a spoon held under a running tap, water moves faster over the curved surface, creating a lift due to pressure difference. So I can actually put a spoon under the pipe, under the tap, and I can see slightly change in the weight that I feel in the fingers. Now we come to the next one, namely metaphors. Metaphor is slightly different from analogy. A metaphor is a direct symbolic representation of one thing as another, not necessarily structurally accurate, but emotionally and intuitively resonant. So when you use metaphor, you have to be careful in comparison to using analogies. Let us start with the example. The CPU is like the brain of the computer. You comparing CPU with the brain, you can go only that far. You cannot start deriving so many conclusions from your understanding of CPU to the brain, nor your understanding of the brain to the CPU. Okay, they are somewhat similar, but not you cannot carry it too forward. But I can vaguely, intuitively understand the CPU as the brain of because the decisions are getting made by the brain. CPU also performs that kind of function. So the instructional purpose of this is to promote intuitive understanding by reimagining one concept in the image of another. That is the instructional purpose. Examples of metaphors: heat flows from hot to cold. Okay. you are saying flows like hot to cold. Okay. Friction is invisible brake. Current is the lifeblood of the circuit. A capacitor is a memory sponge. As we said, you cannot carry too much forward a memory sponge to the working of capacitor, but it is somewhat similar. Maybe it will help you to understand the work of the capacitor in the beginning. Subsequently, of course, you can transfer the ideas into your own using the equations or understanding the physics of it and so on later. But initially you can make use of this metaphor. A column is the backbone of a building. Soil pushes back like a cushion. The algorithm is a road map through a jungle. A prosthetic is an engineered whisper of what was lost. Yes, is it really a whisper of what was lost? But something like that, something somewhat similar to that. That is why we are calling a prosthetic is an engineered whisper of what was lost. Now we come to the third one, namely graphic organizers. Graphic organizers organize the content graphically. The graphic organizers help students organize ideas, see relationships, and facilitate retention of information. They perform two, if you, for example, whatever you are trying to represent as a graphic organizer, using a graphic organizer, if you try to write it as a text, you have to absorb so many things, you may not be able to relate all aspects of what is presented to you. But if I try to put in some kind of a form, some kind of an image, then I may be able to, an image can present lot of information in an integrated way. So I may be able to get a better the entire picture in a concise form through an image, and somehow human brain seems to rather absorb better information through images or some kind of a graphic information. These organizers are best at showing the relational information. Like a simple graph, if you take between x and y, you can write as an equation, but you can also show the relationship in the form of a graph. I can quickly get the picture what is the kind of relation between x and y. Visual representations can be used in all disciplines and are quite flexible in their application. There are endless number of graphic representations that you have, and they can be used by teachers as means to display information to the class. Okay, they can be used like you want to present something, you can first thing you can do, draw a graph on the board, or show a picture, or put a table, or draw a table on the blackboard. They can be used by the students as a student as an activity. Then not only teacher can present information, student can make use of it as an activity, it facilitates your learning. For example, you can give some graphic information, not fully populated, not what do you call it, neither pictorially complete nor any legends written on that, and then the students can be asked to complete that based on their understanding of what the teacher has presented. So if you are able to complete that, that means you have understood that particular concept or that particular piece of information. So the student, he can use it as an activity creating or completing one. Either he can create a complete graph or a complete picture, or partly drawn one he can complete it, and as a means to plan writing, making notes and support to help answer questions or discuss issues. Of course, this requires some kind of a planning. At what stage should you present a graphic information to the student, and what are the things you want him to do? Just complete the picture, or you want him to write something or make his own notes. All that is to be decided by the teacher. So how the graphic organizers are used depends on the objective first. Same thing will not apply to all kinds of situations. It works well to give students a diagram with little text on it, and then ask them to add details as they learn about the topic. That is one example of what I have been stating above. Okay. A teacher can generate or make use of standard templates for the graphic organizers he proposes to use, and ask students to use them to save time. Because if the graphic part is rather complicated, like for example, in the case of you have a complex digital circuit, you are trying to do something about finding the time between some two events, and if you want the student to keep drawing all the waveforms and then decide, it will take plenty of time. So what you do is you use some kind of a graphic information given to the student, and then start working on that to save time in the classroom. For maximum effect, students should generate their own graphics. The simplest graphics are graphs, tables, pie charts and similar things. Okay. And software tools, both proprietary and open source, are available for creating some graphic organizers. Some are available plenty. I think each teacher can explore which are the open source tools that are readily accessible to him, that suits the particular subject matter, and then make them available to the students if you want to use a graphic organizer in the classroom. And if you want them to do something you can also do the same thing in the lab as well. So let us look at tables. Tables serve as a versatile tools for organizing, comparing and presenting data, concepts and relationship. Table can be what do you call multiple column table and several rows. That is what we are familiar with, columns and rows. But the purpose can be different. All tables will be like that, but the purpose can be different. So the types of tables that you can think of is conceptual understanding table. Each concept is one row, and you try to what does it mean, in what context, or for example in what way it can be misunderstood. You can keep on creating columns like that. And technical and computational tables, some we mainly put data in that and do some computation. So some columns will have data and another column will be the result of some computation. And data handling and analysis tables, instructional and pedagogical tables, like what we earlier talked about in Bloom's taxonomy table. Memory and retrieval aids, how do I try to remember? If I can put in the form of a table, maybe I can remember better. Project management and communication table, what is the role of each person, or what is the function of each subgroup. If I want to do that, I can present it as a table and it can be shared with all the project members. Engineering discipline specific table, each discipline has its own specific tables. These are all the types of tables that you have. Let us look at some samples. Observation table, when you do some observations in the laboratory. Statistical table, when you want to compute some statistical parameters. A property table, a definition table, comparison table, classification table, revised Bloom's-Vincenti taxonomy table, a mnemonic table, and responsibility table. So you can add many more sample tables like this. So the tables are a large variety of them are available, and one can use the table as a very effective tool in terms of summarizing information, and also you can make a student engage with the knowledge by asking him to let us say partly fill table and ask him to fill it up, or create a table for a particular purpose, and so on. Now here some more types of organizers. Now they are a little more pictorial. The first one is still a textual, but it is still some kind of a graphic organizer. Basic outline of it can be of a program or a report or anything that you want to do. For example, topic, either it is a sentence or a main idea. Okay, you put as a table title, and supporting details, it can include an example or multiple examples and so on, and many supporting details A, B, C you can add, and continued developing of main idea in whatever form that you want, and you prepare a summary or a conclusion or close it. Okay. So that is how you can organize, let us say writing a report. Different reports will have slightly different structures of this. Venn diagram, many of you would have been familiar with. You can relationship between 3 or 4 things you can draw Venn diagram like this. What is common or intersection between two? We tried to explain that in the earlier course between, let us say, science, engineering, and possibly economics or technology. You can say what is the relationship between some 2 or 3 or 4 ideas. You can draw it as a Venn diagram. And hierarchical topical organizer, something that is easy to understand, like in case of cognitive domain, then we talked about cognitive processes and so on. And bubble topical organizer, here there is hierarchy. Here we do not talk about hierarchy here. In hierarchical topical organizer, you can see the hierarchy clearly. In a bubble topical organizer, we do not see any particular, only these are related to some central idea. You can rotate them around, so there is no particular hierarchy. It is a little more interesting, like a tree, a branch and a sub branch and then some leaves, like that you can present. Okay. These are true graphic organizers. Then there is this fishbone diagram, or it is also called Ishikawa diagram, which is being used for quite some time. When the cause and effect, for example, if there is a problem in a engineered product, the defect can come from due to variety of causes. So we classify these causes and then list those causes under each variety, and then draw it as a fishbone diagram as shown here. You have to populate, you cannot just draw lines, but you have to say specifically what each one is. And when you are trying to diagonalize something, you will start eliminating one by one in that. How do you organize? These different causes in different sequence will depend on the product. So this kind of fishbone diagrams can be drawn. This is another graphic organizer. This is spectrum and timeline. When you want to talk about something along some kind of spectrum will be as a function of frequency, and sometimes as a function of time. Different events take place or different classification we are trying to do with regard to frequency, then you use diagrams like this. Or human evolution, if you want to talk about time scale wise, you can also show like that. Another type of thing is called storyboard. When you do have a fairly complex thing, then storyboard can work as a very good way of a group of students can work on a project or something using the help of a storyboard. It will also be very interesting to the students if you use a storyboard and ask them to interact and actually create a storyboard. Now storyboard is a graphic organizer that visually maps out a process, system or a concept in a sequential frames or panels, much like a comic strip. All of you should be familiar with how a comic strip is made, a series of images which are slightly different, and once you quickly pass through those images you will physically see the movement. Here your purpose is not to show like a actual movement, but sequence of events can be presented in the storyboard form. It is used in engineering education to explain systems thinking, illustrate design processes and facilitate problem solving by combining text, sketches, symbols and flow. Because if you want to mix all of that, the usual report type is not the only one. One can go through a storyboard method and then subsequently at each stage you can fill in more details. Like storyboarding is used in software development as a part of identifying the specifications for a software. During the specification phase, screens that the software will display are drawn either on paper or using other specified software to illustrate the important steps of the user experience. Whenever you try to develop a new software, it is for an end user. And how does the end user want to use it? And what kind of screens that you would like to have for interaction, that can be presented. There is no software backing it up, only the kind of screen that he wishes to see. If they are all drawn, then that will become specification for the actual software to be developed. Okay. Storyboarding is used quite a bit when you try to design new software. Storyboard in engineering instruction, you visualize step by step process or designs if you want to use step by step, and simplify complex and abstract ideas. If you consider the idea that you are explaining is complex, you can resort to storyboarding it. Plan engineering workflows or case studies. A structure of a storyboard, will consist of a number of panels, you can say. That is, I will put in front of you a panel on which something is either written or pictured or there is a photograph on that, and then I show one panel, and then after you understand that I replace it by another panel. So, but each panel like that will have a title or a step number. If you do not have a title, it will at least have a number. Then you have diagrams and sketches and a brief description. You cannot write huge text. Key concepts are equations. Inputs and outputs are decisions. All of them need not be there, but whatever that is relevant, whatever that group thinks with respect to that particular project that you have, they can be included in that. That is how each panel. Let us look at just one example to understand really the importance of a storyboard. A storyboard for a land and river basin survey. The purpose is you are surveying a land and a river basin, because along a river basin you have a variety of things. The soil conditions can be different kind of vegetation can be there, and it also flows in all kinds of directions. And if you want to survey all that and prepare a report for whatever purpose, it could be simply ecological survey, or you want to do something, small check dam you want to build, and you want to understand why, what kind of side effects it can have. But for all that you first need a river basin or a land survey. Okay. The purpose is to represent the process of assessing a river basin's physical characteristics, land use and water resources. It would include scenes of data collection, analysis and the presentation of findings. Okay, you are not limiting yourself to merely sketches or photographs. You are actually, for example, if you say you have a particular type of soil, the nature of the soil data you have to actually collect through measurements and include. Okay, let us look at the typically four stages, and each one can have multiple panels. For example, introduction, opening shot of river basin from a high vantage point. Now these days you can have what do you call a drone survey, and you can have a small video of by the drone showcasing its topography and drainage patterns. Scene 2, transition to a close-up of a surveyor using GPS and other surveying equipment. He is just putting a surveyor picture there, and introduce the concept of river basin and its importance. You have some text. You can present it in one panel, or you can present it in multiple panels. And data collection, scene 4, aerial view of the basin highlighting different land cover types like forests, agricultural land, urban areas. Scene 5, a team collecting soil samples at various locations. Scene 6, an engineer measuring river flow and water quality parameters. Scene 7, using remote sensing data to map land use and land cover. And Scene 8, interviews with local communities about water usage and resource management. Why I am giving a detailed example like this is that when you are storyboarding, you are kind of looking at a variety of information. It is not simply some numbers or some text. For example, if you are interviewing local communities, you may put your voice recordings right on that. So when the people who want to understand this, they want to listen directly in the voice of the local people. And Scene 9, engineers analyzing collected data using GIS software. Scene 10, visualizing spatial data to identify areas of concern like deforestation, water pollution, and modeling water flow and sediment transport in the river basin. simulating the impact. You may use some simulation software to simulate the impact. When you try to interfere or intervene with something, what exactly is going to happen? These days you have good models and you can simulate that to find the impact. Finally, results and recommendations. Presenting findings through charts, graphs and maps. Recommendations for sustainable water management and land use practice. So, you are giving text, you are giving graphs and tables, stakeholders discussing the findings and proposed solutions. The discussions can be completely recorded and presented. Conclusion highlighting the importance of river basin surveys for environmental conservation and resource management. If you can do, if let us say a civil engineering student can participate in one such storyboarding of a kind of a survey, even one survey, his understanding of the whole civil engineering will so vastly improve. He gets a feel for that, not merely by listening to some lectures in the classroom and writing an examination or reading a textbook, but you can personally experience all these dimensions. That cannot happen without, that is, if you are talking of higher orders of learning, storyboarding, an experience in storyboarding can greatly help. Okay, in the next unit we will use, we will try to understand the use of concept maps, concept inventories and mind maps in instruction. And thank you for your attention.